So how does this connect to like all the side work you do? Like for example, you mentioned you've been looking into the interpreter stacks, which I don't know what that is. You can tell me later.
Yeah.
Does that connect to work?
Not so much. No. A lot of the work I've been doing recently, both at Cognitect as well as now here at Cisco, is more around logic engines and query engines and that sort of thing. We have a lot of data stored in different places, and a lot of data stores have a lot of different properties. You do a lot of work at Datomic. You're well familiar with how, Datomic has some things it's really good at and kind of some holes in other areas. Maybe stuff like what's the word I'm looking for here? Materialized views, and if you have a query you want to run, you want to get triggers set whenever some data matches a query in the database, that sort of thing. Those are areas that Datomic maybe isn't so good at. I do a lot of work with Elasticsearch now, and Elasticsearch has no support for joins whatsoever. It's not relational at all, but it's really fast, and you can store a ton of data in it. And so a lot of the work I'm working on is kind of just like providing tools for people to be able to query that amount of data efficiently. So they can hand us a query, and we'll analyze the query, optimize it, and find the most efficient way to talk to Elasticsearch. And that uses a lot of the logic engine stuff I've done some talks on and things in the past. Kind of our own version of Datalog, but even Datalog has its, Datalog is a set-based thing. So in Datomic, if you say, give me these results, but I only want the first three, all data logs are like this, by the way. It'll find all the results, throw away all of them but the first three, and hand you the first three. And so that's not so good when you're working with, what could be billions of results. You can't find them all. You don't want that. You want a more lazy approach to finding results. And so a lot of the stuff I've worked on really in the past 3 years or so is a lot of that, of just saying, I know I want the first three results. Can we get those efficiently? And then if I can come back later and say, I want the next set and the next set, and doing that across data stores that maybe don't have any concept of joins, which is fairly common. Cassandra, Elasticsearch, React, although I don't know if that's still a thing or not. Those are all data stores that, or, databases that have no concept of joins or relations or, that sort of thing. So, yeah. So, so that kind of overlaps with a lot of the interests I have in programming languages and that sort of thing, and that these are kind of optimizing logic engines that have a kind of a programming language interface, right? The user's going to say, find this where this is true, and you got to kind of interpret that. And so there's a lot of overlap between those two.
That's really interesting. One of the things I think about is, because with Hyperfiddle, we're trying to make you get Datalog to express, and that can express a lot of especially simpler CRUD apps. But what type of things can't it express? And what types of things might, you could have this other query language. What might we not be thinking about that you could express that way that we can't express today?
Yeah, so I mean, as long as your data set's small enough, I mean, Datalog is going to be way faster than like a Prolog approach, or Minicanron or CoreLogic or something based on those things. It's kind of a lazy, and all at once set-based approach is faster if you want all the results. But the one thing that I would love to see people investigate more, and there's been some very small attempts in this, is that there's a whole nother set of engines, logic engines, if you want to call them that, called reading networks or rules engines, where
right.
Where you build the query once and it sits there and the query doesn't change, but as you put new data into the engine, it'll trigger new outputs. So this is the classic, if you ever say, I want to know when this query would return an additional result.
Have you looked into what Nico's presented at the conj?
I don't know that I have. Is that the one? That was the talk you did earlier that you sent me, right?
I linked it. Yeah.
I have not seen that yet, but yeah, it's a lot of the same sort of thing. It kind of runs in the engine. It's interesting because Datalog is this idea of our query is going to change, and relative to that, the data is not going to change that much.
Right, and this is the opposite. Yeah,
the opposite. Yeah, exactly. The data is always changing, and your queries aren't really going to change.
So here's the big question, then, from my perspective at least, is if you've got Datalog on the one hand, the pull based, and then you've got the incremental streaming based network or incremental data flows or whatever. Like, what are the holes in that? If you can assume both of those are good, what
No,
else?
I think
That's it.
that's yeah, that's pretty much it. Aside from maybe a streaming result, you know, a lazy something that allows you to lazily produce results from the system and go back later. Prolog had that back in the day, that you could say, you could tell it, you know, get me a result for this query, and it runs until it finds one result, and then you can say, get me the next one. Now get me the next one. You know. Unfortunately, with that, one of the downsides is any sort of sorting is really hard to
It's
do.
impossible, right?
Yeah, really, it really is. Yeah, unless you do a whole lot of tricks, which I've done in some systems where it's like the back end. If the back end knows about sorting, you can kind of let that flow through the whole system. So if Elasticsearch or whatever can give me the results in a sorted manner, pre-sorted, then I can kind of flow that through the system, and my results coming out the other end are sorted. But yeah, it's sorting is. If someone said sorting is no longer a thing in this world that we know of, I would be a very happy person.
One thing that seems interesting, if you look at bigger systems like, say, Facebook, like Facebook comments on like the president's page, there's millions of them.
Right,
If you
right.
just have the linked list approach of like, hey, we're just going to traverse one node at a time, and the order is inherent in that. Does that cover all the use cases that people want pagination?
You know, that's interesting. I actually haven't thought about that. I think one of the problems is just people expect arbitrary sorting. I mean, that is a sorting based on time that each
Right.
person, you know, if you said, I want all the comments made about the president sorted by name of the poster, that's a little bit harder to do. You'd have to then have two lists, you know.
But that's not an interesting query because there's 10 million of them.
Uh, yes and no, right? I mean, like in that context, no, it maybe is not interesting, but in a different context, depending what the data set is, you know, um, uh, a lot of the stuff, you know, we work with would be things like, I may want to see all the viruses that have that we've seen recently sorted by a threat value that we've assigned the virus, or then sorted by, you know, the domain address that they talk to. I don't know. I'm pulling stuff out of my head here, you know. But yeah, there's cases like that, and the true part of the story that I'm sure you're familiar with is that if you're doing UI work, everybody just expects you click the header at the top and it sorts, and you click it again and it inverse sorts. That's just the way the world works, you know. Yeah.
Well, we're going to find out. Yeah.
Yeah.
I had a thought, but I lost it. You were something about what you said about sorting by threat value was interesting. Oh, because if you have the incremental data flow, it's like aggregates, right? You can materialize it and do the sorting in that end view incrementally. You can
Right.
keep inserting to the right place, so you can actually solve it.
Yes, you can. Now, of course, the problem there with a you know, a rules engine, you know, and I have to look at the incremental data flow, but I imagine it's kind of the same sort of approach. You know, the kind of the problem with that is if you want to sort by a new thing, or you have a new piece of information, you have to change the network and backflow any.
Right. You have to know at compile time.
Yeah, exactly. And there are systems where you can add a new rule at runtime, but a lot of those also involve then re-ingesting history into the network to repopulate anything that, because a lot of these systems to save memory will just throw away any information you're not interested in the compiled query, you know. So that's actually a problem that I've seen in some systems is, you know, okay, great. So if we built this system, whenever we add a new rule, we would have to shut down the server and restart it, or throw away the data flow, or just the fact of ingesting 10 months worth of data would just take a long time. So yeah, nothing's ever for free. But I've often wanted that sort of thing of being able to have a engine that kind of can do both. The same query language could express both pull and push based, because there's almost always a time in a system where someone will say, hey, this is great, we can query your system. Can I give you a query and you give me a data feed, and you just push to this endpoint whenever you get a new match? And that's hard to do without writing.
That Datalog makes it possible, because to some extent this is all a moving target. It's like, what is the world going to be like in 5 years, and what are the capabilities people are going to ask for in 5 years?
Right.
And given the operational transparency of the way the Cognitect technology works, right, I can see a path forward where there's incremental data flows running off of with parity with Datomic, where you can run the same query both ways.
Yeah.
I couldn't
Yeah.
see that happening in any other system.
Yeah. There's nothing stopping that from happening with Datomic's good Datalog language. I mean, you could use the same syntax for both. I worked on that for a while, and I thought there was a couple things. Oh, it's aggregates. Aggregates and the like are real interesting when you get into like a rules engine, but there's no real way of expressing those in Datalog, and there's really no reason to, because you do those in closure code currently. So there is a little bit of that. But you could definitely extend Datomic's Datalog to do more.
Or just re-implement it in different ways with different operational
Backends, yeah,
characteristics.
yeah. And that was even the question when I was working on that was do you then target the Datalog, or do you provide an abstraction above it to say, hey, you're going to write in this top level language that understands aggregates and all this, and we'll compile the Datalog, or we'll compile to a Clara rules or whatever. And I just never got down to writing that, mostly because these things just take a long time to perfect and build. And I'm still tweaking what I've written for Cisco, and I'll probably be tweaking it for years. There's always something to improve or change. What's fascinating to me about it, though, too, is that there's a lot of business logic that you can bake into an engine when you write it on your own. So there's a classic thing here with Datomic, is Datomic does not provide an optimizer for their query language, because Datomic doesn't store statistics about attributes, and there's not just a whole lot that an optimizer could do. And as Rich has said, the optimizers work great until they don't, and then you're sunk, but in a business situation where the data you have, you can leverage that a lot more. And I've done that in some projects where I know, this could blow up, or this could be highly inefficient, or we could have gigabytes of data in this attribute, but we won't. And so we can pre-calculate these values, or, this thing doesn't change often enough that we care. Statistics would be a good example of that. So I wrote a system that was for a bank, and a part of the calculation was optimized based upon the average size of a portfolio of trades, or something like that. And that's a value that will change over time. But the assumption was, if the system's been running for years, the average size of a portfolio isn't going to change that often between server restarts, so you can cache that at the start of the server, when the server starts up, and you're going to push new code in 2 weeks anyway and blow it all away.
So at what layer do you bake in these optimizations?
Oh, we were putting these in. We would have like a layer that the user would use, kind of like we were using like Instaparse to parse whatever code they gave us. That would come out into an AST, and then we'd run on like a nanopass compiler over that. So a bunch of passes over the AST to refine it. And part of that, what I was just mentioning, was like a partial evaluator of saying, we're looking up a portfolio by an ID. So we could go hit Datomic, or we could cache all the IDs in memory of all of our portfolios, because there's only X amount of them. And then we can replace that ID lookup. So that just removes one join from your Datalog query, right? And if you look that up, maybe the next thing that you were going to look up in the chain, you could also partial evaluate. So there were some times when you would run the partial evaluator, and come to find out, through the entire query, you're only ever dealing with one result. And that's actually what the partial evaluator do, is it would run a clause and say, like, do we think this clause is only going to return one result or 10,000?
Because one thing,
it would try to look up one result. And if it found one result and that was the only one,
it would optimize for that.
It would optimize it away, and then it would go through. So there are times you'd run the optimizer, and it's just like, the result is a constant. It's just 3 or whatever,
Facebook has this layer in their GraphQL implementation where, like, you define the queries, but since they're known at compile time before you deploy, you can like use that as an interface to inject hand-coded implementations of the query, or hand optimized version, but without exposing the user interface developer to realizing that there's an optimized path. So
Oh
that
yeah,
was
yeah,
just
yeah, yeah, interesting. Yeah, in
Mhm.
fact, that's something I've been doing a lot of work with GraphQL, and that's something I want to try to do is do that on a somewhat of an automated basis to say, okay, you gave me a GraphQL query, I have an AST, I've optimized it, I know what I'm going to do to the servers for that query.
Mhm.
I would love to be able to make that like a stored procedure, which GraphQL kind of mostly allows for, where you could have variables, so you can plug in your variables, and now we can just ignore that optimization pass and run the same query for different variables. Um, as it turns out, though, for a lot of that, it's like closure is really fast. And like in a lot of these systems, that optimization pass is like 20 milliseconds. Um,
Right.
and at that point, it's like, what's the point? I mean, until you get to the problem of, hey, 20 milliseconds isn't fast enough. So much more in the system, response cycle is higher. It's going to take longer to JSON encode the data than run that optimizer pass. So
But that's what's cool about doing it after the fact is you can just like forget about it until it's a problem, and then you can start injecting,
yeah,
keep a
exactly.
checkbox and bypass it in this other way, and that's you know not expensive to do.
Yeah, exactly. That sort of abstraction, and that is the goal with GraphQL and a lot of these systems as well. Is like, hey, now the developers can change the back end without changing the interface the users use. Yeah.
What do you think about GraphQL overall? Is this something that you've been asked before?
No, it hasn't. I haven't. Well, not publicly. Um, it's it's great. I like for what it's trying to do. It's great. I don't think um, closure needs it. To be honest with you, like
tell me why.
because it's I don't know what the language is they wrote GraphQL for, but like what is that? It's not JSON. What is that syntax, right? No, I think the biggest thing is it's not data. The response is data. The response is JSON or preferably Eden or Transit or something. But the query language itself is kind of weird. And I actually there's two areas of things that I've hacked around GraphQL because it doesn't support it properly. One is or. There's no logical or in the language. So there's no way of saying, get me people whose name is Tim or their name is Bill. You have to either do like an array, but then you can't do arbitrary binary logic. So you can't say his name is Bill or Tim or they live in Chicago. Because there's no way to group those or clauses in the way I just said it. And even the way
Right.
I just said it doesn't make sense in English, but you get the point. And so,
But you could name a collection and then have like relational logic on an implementation of it.
name a collect. I mean, like what you can do. Well, what I've actually ended up doing is just I have a input variable that's JSON, and it's a AST as JSON. I mean, and it's gross and it's ugly, but hey, it works.
Okay.
Yeah, the other thing too is there's no way to express. So if you have a GraphQL and it's a tree, right? You can provide parameters to the children. So I can filter the parent and I can filter the children, but there's no way to filter the parent by the children. So let's say you have people and you have vehicles that they own. You
Okay.
can't say, and so you can say find me all people named Tim and list their cars that are made by Ford. But what you can't say is find me all people who own a car made by Ford. You actually would have to invert that in GraphQL and say find me all cars made by Ford. Now find me the people that own those, which is not what the original query wanted either. You want a way of saying like people.cars.make equals Ford at the top level and have that filter the people that are returned.
But surely there's a way to just use GraphQL as like a poll language, but not a filtering language.
Yes, and once again, that's also what I've done is that I have an attribute just called query, and
Right.
inside that's a string, and you can give it arbitrary, JSON or you could do Solar or whatever syntax you want, right? Um, and yeah, that works. It's just it's funny because all of that is rectified by just using like Eden or JSON as the input, and so that's the one thing I'm not sure that I agree with GraphQL is that I think they should have just had JSON be the input. And I know they want it type checked and all this sort of stuff, but you could have type checked JSON as well. But whatever. I think part of it is, I mean, GraphQL does look cleaner than a blob of JSON, in that, you know, the names, your labels, the keys in your maps aren't in quotes, that sort of thing, that you can say, you know, person colon name. But hey, machines write these things, not humans, in production. So what's the point? Yeah.
So I'm trying to understand what you meant when you said Clojure doesn't need it.
Yeah. So Clojure doesn't need the GraphQL syntax, like
I see. Okay.
the actual syntax. Like Clojure's interface could literally be Eden in and Eden out, or transit in and transit out. And you don't even necessarily need like spec would work, like whenever we get data specs, like specs as data, where you could actually download the specs. That's something I think at that point, you basically don't need GraphQL at all, because what you have then is you could have an endpoint that says, get me the specs that you're aware of. You download the specs into the client, ingest them, process them, whatever, and now you can type check your request, and then your request is just, you know, entity name, person, fields that you're requesting, list them out in an array of values, you know, what's the filter, that sort of thing. It becomes an AST. It's a tree.
Okay, so when you say spec, you mean spec and also probably like the schema. Like if you translate this into Datomic, which is more Eden-like,
yes,
you've got a schema and you've got a spec, and they're kind of the same thing. They're, you know.
Yeah. I mean, Datomic's schema is much more data dependent. You know, like you don't necessarily say in Datomic, this needs to be a string of 5 characters where the first character is a capital T.
But you do know it's a string, and then you've got the specs to give you.
Yeah, exactly.
Yeah.
So, yeah, I mean, the perfect future I would love to see is where we have specs, Clojure specs as data, so you can introspect them and generate them and transfer them across the wire. And then you could derive your Datomic schema from those specs.
Yeah.
So you could just add a new attribute to an entity that tells you then what needs to go in the database, update the database accordingly. And then, yeah, you can check your inputs based on that too. And so it's fascinating, because a lot of what Rich talked about at the Conj resonated with me, as far as, you know, the features he wants to add to spec. I've felt a lot of those pain points of, you know, well, a person at the web level is different than a person at the database level. You know, there's a 2-field difference, but it's more or less the same thing. I don't want to keep creating types at every layer, you know,
right.
As well as just a lot of the relationship stuff. He kind of hinted on this in the talk, but the example I give to people is currently in spec, it's really hard to spec HTTP. Like if you want to write a spec that checks the request and response of a REST endpoint, that's really hard, because the type of a child is dependent upon the error code of the parent. So if I get a 500, then I expect the body to be this. That's really kind of hard to do, that sort of polymorphic, because the parent is an HTTP response, which is status, body, and this sort of thing. Yeah. So hopefully that sort of stuff is improving. Sounds like it will, but we'll see when it comes out.
That'd be really cool. It seems to me like there's a lot of the industry is figuring out a lot of things that weren't figured out before, like in the macro sense, like functional programming, even in the last 10 years, and how to properly architect apps. And it seems like everywhere outside of Clojure, there's a lot of ad hoc incremental advances stacked on top of each other. But Clojure is the only place I know of that has a thought out and principled derivation of them in a way that fits together cleanly.
Yeah. I mean, with some holes, right? I mean, I think we see that within Cognitect products, perhaps. Well, mostly between Clojure and Datomic, but I mean, like, I don't know that we've found the end all be all for like how functional apps should be written, like the web stack should be written, right?
Right.
I mean, the ring still revolves around a lot of, you know, well, it's a function that takes a single argument. You know, there's a lot of side effecting and that sort of thing that's still happening. But yeah, I think Datomic is really the realization of what would happen if you put a data structure on the disk, you know, a persistent data structure on the disk.
Now, when you say web stack, you're talking about like lower level implementation stuff, right?
Yeah, well, what I'm saying is that like as far as you look at Datomic and you look at Clojure, and they fit together very well. It's still that succession time model. There's a very clean connection between the two. You can tell they're both written by the same person, right?
Yeah, I'd go so far as to say they're the same thing.
Yeah, exactly. But we don't see that through the entire Clojure ecosystem. Like,
well, that's true, right? Because no one uses Datomic.
right. And so I would go so far as to say, you know, I think we can see a glimpse of what a perfect Clojure app would be. You know, and to be honest with you, I've seen that more with, you know, Pedestal's got its problems, but for all of that, there is some very cool stuff you can do when you've basically, what Pedestal does is reify the call stack of the application. And, you know, what Ring has in a bunch of handlers and middleware where you walk up the stack and back down. And so, hey, I work with Liberator and stuff where, you know, you get an error and your call stack is like 200 frames deep of decision trees in Liberator. In Pedestal, that's all in data. It's all in a giant hash map that basically says, here's the steps we will execute on our way out. And so it's very possible to just take the entire call stack of a Pedestal application and just just save it somewhere. You can run it on
that's interesting.
you know, you can go somewhere else. It's kind of like it's the entire web request as data, including the frames, the stack frames. And it has interesting properties for like testing and introspection, debugging, that sort of thing.
Even that's all pretty low level for me. Like, I'm after more of a vision where, like, what would it take for my mom or my kids, my future kids, to be programmers and yet not be professional software engineers? Like, all the web stack stuff is all like a layer underneath what matters, because if you've got specs and you've got Datalog and you've got both types of Datalog that you need, the pull one and the incremental one, right? Nowhere in there does it matter that it went over an HTTP request or not.
Yeah, you know, it's an interesting question, and it's one I think that's been asked for years.
And in fact, why can't you like press a button to switch out your implementation to have it go over a WebSocket now, or to have it whatever else there is in 20 years, same application run on a different like IO implementation strategy?
Yeah, you know, it's fascinating because on one hand, I kind of agree. I mean, I remember learning programming back when, you know, I was doing HTTP and HTML and PHP and that sort of thing. And that was something. I bought a book on PHP. Fun story. And I learned C before this and all this. And I have friends that are like, "What is up with it?"
Are you like 15? You seem like you're about my age.
Yeah, roughly about that time, right? You know, but I knew C. I knew C beforehand. So I pull up this book on learning PHP. I literally spent like 3 hours reading the book, and I'm like, this is stupid. I know it all now. Like, literally, I can set this book down and write a web page, because all the names were just, people are like, why is it stir to take a substring of a string in PHP? It's like,
right,
that's what it was in C. It makes sense, you know. But yeah, so all that to say, there is a problem in programming today, and that, you know, I learned to program in GW Basic and QBasic and that sort of stuff. And there's Scratch today. There's is it Scratch that uses the Lego things? I forget. I don't know.
Logo. Yeah, I don't know.
Yeah. But, you know, a lot of this stuff is just really, really complex. And I think it's really hard to write something that's both powerful and useful for the average person.
I don't think the JavaScript, GraphQL, Facebook, whatever, I don't think that stack is ever going to get there. I think there's too many holes. As you described, like GraphQL gets like 80% or something, but it'll never get all of it.
No. And I don't think that's I don't think, I mean, maybe they claim that's the point. I don't think it's that. For me, it's more about, um, with GraphQL, it's more about just like interop with other departments. That GraphQL literally runs on anything, like any language out there that can talk to the web. There's a GraphQL client for it. And so it's that idea of being able to just say, hey, yeah, you got your GraphQL client, go download the schema, tell me if you have any problems. Um, but
That's cool. Well, because like if you try to extrapolate like what could happen with Clojure, I don't think it's reached a critical mass yet where all the benefits that we've been talking about have really like reached a point where anyone can achieve these benefits. It takes a lot of work right now.
yeah, and I think there's something I've seen develop in Clojure recently, and that is a lot of the recent developments in Clojure are very enterprise focused, and
Huh.
as far as like Datomic ions, I have I have friends. Okay, give you an example. I have a brother who's a mechanical engineer, ME and EE engineer, kind of rides the line between the two of them. And he knows enough programming to be dangerous, right? Like if he needs to test some circuitry, he can write something that it targets an Arduino board or whatever, does all this stuff. He couldn't care less about Clojure. And it's one of those things where it's like Python does anything and everything he would ever want. And I see that as one of those areas where like I don't think Clojure is pushing into the accessibility. At least I haven't seen it push more into the accessibility world. And
It
I don't
may
know
not
if
be
that's
time yet.
what was that?
There's an order in which you have to do things, and it may not be time yet.
Yeah. That could be. That could be. I mean, I don't know what the world's going to be like too, but the area I see Clojure moving into is more the enterprise place
But you have
where
to go there first, right? Because if to have something that's easy, it also first has to be proven complete. And to prove it complete, it means people are using it in real world circumstances, and it's better.
yeah, I don't know that I would agree with that because other languages have started in the other at the other end of things. I mean, we could say what we want about decisions Ruby makes or Python makes, or hey, even PHP. PHP is still like the most popular programming language on the planet.
But it was complete. Python, PHP, all these were still OO imperative languages, and they didn't take any risks relative to. They're like a little better than the thing that came before them, right? Or even a lot better, even right. Python was a lot better than C.
Right. But what they focused on was ease of use and accessibility over all else. And that's kind of what I'm saying is that I don't know that Clojure, maybe someday Clojure will focus on those things. But what I see it focusing on and has focused on for the last 5 years is very much more solving hard, solving hard problems faced by enterprises, running Clojure on ions or even Datomic, all the new Datomic stuff runs mostly in AWS, and that's the running problem, right? Is it's like when I was a kid learning programming in C or whatever, it was like, where can I find a free C compiler? Okay, we're going to use DJCPP, which is GPP for G++ for the DOS, and it was like, you get all that. That's kind of where your thing is. If the barrier of entry is you need a system that can support, a 2 gig runtime just to boot whatever you're running Clojure on. And it's about 2 gigs. It doesn't even matter what, like, if you're using Cursive or Emacs or whatever, you need about 2 gigs of free RAM to just get Clojure up and running. And then it's all the cool stuff, Datomic and that sort of stuff is ions. I mean, or in AWS, $1 a day is dirt cheap, but that's still more than a hobbyist will pay. So
Yeah.
now the world is setting up something free and even all of that, like
What if you didn't have to set it up?
well, that's the thing. Like, what if you didn't have to set it up? What if it was completely free? What if you didn't have to pay? What if it was open source? It's like, it's all the same sort of thing of just like, you're still kind of in that world of it's more work to just get running, it's not just download this one executable, click run, and now you can be programming. So I'm not saying all this disparagingly towards Clojure. I think there's something that someone mentioned to me. Oh, well, it's just pure economics one. It made a lot of sense to me. Is that optimizing for the ease of use has very little return at the end of the day. That, you know, like here's the example. I should make this very clear. I do not work for Datomic, whatever. I do not speak for them. You know, from my side of things, it's like if Datomic was free, what would that gain Cognitect? You'd get more users maybe, but in the end, that's more people to support that probably are just going to putz around for a while and then not use it, you know. And that's the problem with any product. It's like if I give it to you for free and you want help with it, now I'm spending my time for free supporting something that I'm getting nothing out of it. It's not economical, you know. And even providing a free trial or an inexpensive version, or, you know, here's a version for educational use or whatever, it's an economics of you know,
the paradox
what's
here
my
is
end
that
goal there, you know.
tech markets are winner takes all. So it is a paradox. Like, you can give it away for free and then maybe you didn't win and then you wasted your time and your money.
Yeah.
Right. So you need to find the balance and then maybe flip a switch where you reach the point where, okay, now it's free. And
Yeah. Yeah. And there's multiple ways of looking at it. I have never heard this officially, but the old adage, and I've heard for years, is that, you know, Adobe never prosecutes students in college who pirate their software, because they know the first thing they do when they leave, or they're going to go and demand their employers buy it, you know. So there's always that aspect of if you can get people hooked on the software. But I mean, I guess what I'm saying is too, there's a whole area, the whole area of enterprise is based on this idea that disks are cheap. RAM is even cheaper, or I guess to some extent. You know, processors are cheap. The thing that you know, I tell new programmers that I come in contact with, it's just like, yeah, you know, you have to get over that fact that writing the code faster, you know, writing faster code saves the company money. It probably doesn't. And there's times when I have to sit back and say, wow, this is inefficient. I could optimize this code.
I see what you're saying.
But why? Yeah. You know, it's cheaper. It's actually cheaper for the amount that the average developer in America is paid. You know, pay them for 3 weeks or just buy a new server, you know. And that's the unfortunate aspect. But that dynamic is different in embedded systems and game systems, and you know, any small, you know, a desktop application, anything like that. And I think that's why, like, you know, I did some work with JavaFX and stuff too. And that's really the problem with a lot of that is it's like, so I'm going to go write an application. I wrote an application in JavaFX with Clojure, right? And it takes, like, it all boots up once the whole thing's up and running. The JVM's using like a gig of RAM or something. And then I rewrote most of that in C#. And it uses 10 megs of RAM, just because C# is optimized for this desktop environment, reduced RAM usage. You know, it gives memory back to the operating system as soon as it's done with it. It was C# versus Clojure, you know, mutable versus immutable and that sort of stuff. I don't know. I don't think the benefits are necessarily there for running desktop applications. But yeah, the whole market's shifting. Who knows? I don't even know what people would write desktop applications for anymore. That's something I mentioned on Twitter a while back. I would love to see somebody write something in a functional language that's not a web app or a backend service or an enterprise thing, you know.
What you need, the way the system works is too imperative.
Yeah, exactly.
Once that gets so many layers, it almost gives you more opportunities to insert abstractions.
Yeah, exactly. And you know, I would love to see, you know, hey, tax season's coming. What would a tax application look like written in a functional language? You know, whatever those things are written, it's got to be horrific. You know, yeah. And then, you know, there's all sorts of apps on the desktop, but most of what I see, actually, I think what I actually said was I would love to see a non-CRUD app written in a functional language, because there just aren't that many of them. You know, most of them
web stacks also, they're about information processing, whereas the desktop apps, are more about effects, like
Yeah.
on the screen or something.
And presentation and that sort of thing. Yeah. But as we've seen with React, I mean, you can put a functional veneer over that effect.
Yeah, but React is pretty slow in the small. You don't write games in it, right?
Right. Yeah, exactly. Which, shout out here to Arcadia. That's what they're trying to do with a lot of their stuff. Is they're the people behind the .NET closure implementation targeting Unity.
Yeah.
And
I
so
tried to use that 2 years ago.
yeah, so I think they finally got funding. So now there's like full-time people working on it, and I think it'll get better in the near future. But and then if I always have to mention this too, there's 2013 QuakeCon. John Carmack got waxing eloquent about Haskell and functional programming. He's the guy who wrote Doom, for anyone who's not aware. And he started talking about how you could write a functional language, write a Doom-like first-person shooter in a functional language. It's about 40 minutes in. I'm sure there's a link to it online. So just, Carmack talks about Haskell at QuakeCon 2013. But he describes like a garbage collector and all the mechanics you would need to build the system. Because his whole thing was, at the end of the day, an FPS is tracking like 8 megabytes of mutable data. Everything else is assets and textures and all that. And that it's very much feasible to write a functional language. Write that sort of thing in a functional language. Except there's still problems, which is things you would never thought of. The one example he gave is in a purely functional world, two people come up to a door and now they both want to walk into the doorway. So you're here, next frame, you're both trying to walk into the doorway. That's a problem that requires communication between the two things. They both can't walk through the doorway at once, and that's actually fairly hard to do in a functional language.
I wonder. Well, it seems to me that like if you look at the way software evolves, it can evolve for stupid reasons. Like OpenGL is written in an imperative style API because the hardware is imperative, right? And thus the layer above OpenGL, well, because OpenGL is imperative, it takes a really smart person to figure out how to turn that into like a garbage collector or virtual DOM or something, right? To make that function. It takes a person who's paid to do the work in order to make another imperative layer on top of it. It doesn't require brilliance. So you get these stack of things that are just like written in terms of the thing below it.
Yeah, I mean, I think that's definitely the case.
So I would want to see. I don't know. I would want to see turtles all the way down if I.
Yeah, exactly. So I would love to see that